Hello guys and welcome to my channel. I'm Melvin Colley, an engineer and a mathematician, and I will be telling you the fundamental as it relates to differential equation. Okay, we will be talking about the fundamental as it relates to ordinary differential equation. So once more, welcome to my channel. Uh, in the future, I want to be able to come up with more videos on the course differential equation, ordinary differential equation. So you should know that differential equation is very important, especially to us mathematicians and engineers. Okay, we use differential equation to be able to solve real life problems. We are in a 3D dimensional world, so differential equation is very useful. Remember, in did you see this in your high school? You have like x plus 5 is equal to 1. So x will be equal to 1 minus 5, right? And x will be equal to negative 4. So it's like almost you want to find a solution for a particular stuff. So it's almost there. So yeah, I can write this guy as x by dt plus 5 will be equal to 1. And this is what we call, this is a differential equation. It's an ordinary differential equation. Why? Because it contains derivative. So differential equation is an equation that contains derivative. So I hope you are not going to forget about that. This is very important. Okay, so we are going to start on the basic step by step. Today we will be talking about eliminating arbitrary constant. Constant. Okay, so I'm going to share with you two methods that we can use to be able to solve that. So let's get started. Let me give you the problem. Okay, so we have a, we have y is equal to ds squared plus ex plus f. So remember, in eliminating arbitrary constant, we look at the number of constant we have in the equation, because the number of constant will tell us how many derivatives should we take. So here we have three constants, d, e, and f. They are constants. So since they are free, we are going to take the derivative 3 times. If we have two constants, we take the derivative twice. So the number of constants will tell us how many times we should differentiate. So in method 1, now I want to differentiate. So if I differentiate this problem, if I differentiate y, remember from calculus 1, is y prime is equal to, if I differentiate this guy, is 2d x. When I differentiate this thing, is e. The derivative of a constant is 0. So I'm not going to write it. So my y double prime will be equal to, if I differentiate here, I will have 2d, and then the derivative of a constant is 0. Okay, just for fun. So this is d. So if I take the derivative, if I take the derivative of a constant, it's also 0. So I know that y triple prime is equal to 0, which is a solution to this problem given us. So if I should use the method, the matrix, using the matrix, what I'm going to do, I'm going to bring this y this way. So I'm going to have negative y plus ds squared plus ex plus f. So if I take the first derivative, I'm going to get minus y prime. So if I take the derivative here, remember in calculus 1, if you were asked to take the derivative of anything, we multiply the power times the coefficient and we subtract 1 from the power. So 2 times 1 will give us 2, and that x1 is being subtracted, and we just have x. So you multiply by the power by the coefficient and you subtract 1 from the power. So it's what I'm doing. So if I take the derivative here, I'm going to have 2dx plus e. So I want to take the second derivative. So if I differentiate y prime, I will get y prime prime. Plus, if I differentiate this, I'll get 2d. Okay, so if I take out, this is a constant just to fill up the spaces, I'm using 0. So let us take the chair. So here I will have y triple prime. The derivative of a constant is 0. Okay, so I'm going to write this guy right here. So here I have y prime. I take only the coefficient 2, 1. The second minus y double prime. I take the coefficient 2, 0. Minus y triple prime, 0, 0. So remember in high school, you did matrix using the Crimea rule. So we used it 2 first column and 2 and 0. So negative and positive, remember that. So we draw our line, we draw our line, we draw our line. So we draw our line, we draw our line, and we draw our line. This will be equal to, so there is a negative up, so 2 times this value times the negative will give me positive 2y triple prime. And then this guy go to 0, go to 0, 0, 0, 0. So this guy will be equal to 0. So if we divide by 2, we're going to have this and this cancel. Y triple prime will be equal to 0, which is the same as this equation. So you see, we can use these methods to be able to eliminate arbitrary content. So I just hope this will help you. Okay, so let us go to the second problem. So I'm going to clear this. Okay, we have y is equal to c1 plus c2 e raised to the 2x. So know that we have two arbitrary constants, so we are going to differentiate twice. So using our method 1, y prime will be equal to the derivative of a constant is 0. So I'm not going to write that. So if we differentiate the second term, we have 2c2 raised to the 2x. Okay, so take the second derivative. This guy will give me 4c2 e raised to the 2x. So what I'm going to do, I want to eliminate these constants. So I have a system of linear equation in 2 variables. I want this and this to be the same or opposite sign. I can multiply it by 4 and 2, and I can decide which one to make negative. So if I do the multiplication, I'm going to have 4y prime will be equal to 8c2 e raised to the 2x. So if I multiply by negative 2, negative 2y double prime will be equal to negative 8c2 e raised to the 2x. So here I can cancel these terms. Why? They are the same and they have opposite sign. So if I do that, I'm going to have 4y prime minus 2y double prime will be equal to 0. So I want to rewrite this guy as minus 2y double prime plus 4y prime will be equal to 0. So I can multiply by negative 1. So 2y double prime, negative and positive is negative 4y prime will be equal to 0. So what I'm going to do, I want to reduce this. So reduce by 2 is y double prime minus 2y prime will be equal to 0. This is the equation, the differential equation of the problem. So you can see that there's no arbitrary constant in this equation. All right, so let us use the matrix that keep our answer. So we know that our answer is y prime minus 2y prime equal to 0. So I'm going to erase this, and then we use method 2. Talking about the matrix. So in time, because I love linear algebra, so I will be coming up with some videos, good videos on apply linear algebra as well. So be patient, guys. I'm going to come up with more videos. I'm going to share with you what I have. All right. So that question we had was y is equal to c1 plus c2 e raised to the 2x. So what I'm going to do, bring this guy across, negative y plus c1 plus c2 e raised to the 2x. So there are two arbitrary constants, so I'm going to differentiate once. So take the first derivative, is y prime. If I differentiate the constant is 0. If I differentiate this guy, it becomes 2c2 e raised to the 2x. So I'm going to take the second derivative. So remember that in calculus 1, how to take derivative. If you have y, if you take, it's like implicit differentiation. If you differentiate in y, is y prime. Y double prime, it becomes y triple prime. Okay? So here I have plus 0 to fill out the spaces. Here I will have 4c2 e raised to the 2x. So now I have this system. I'm going to put this in the matrix. So I hope you remember your high school using the Crimea rule. So here I'm going to write the coefficient. And so here is minus y. The coefficient is 1 and 1. And then the second one is minus y prime is 0 and 2. The third one is minus y double prime 0 and 4. So repeat the first two columns, and 1 minus y prime and 0 minus y double prime and 0. So remember how to use the Crimea rule. Okay, so there is negative up, is positive down. So this term go to negative 0, 0, and this one becomes negative and negative positive. So I have 4 y prime. And this term, so here I have minus 2y double prime will be equal to 0. So what I'm going to do, I can rewrite this guy as minus 2y double prime plus 4y prime will be equal to 0. So I can multiply this equation by negative 1. So here I have 2y double prime minus 4y prime will be equal to 0. So I can reduce this equation by half. So y double prime minus 2y prime will be equal to 0. So you see, this is the same with our first method. So I mean, you can choose which one, depending on what your professor or instructor will ask you to do. Yay! So guys, can we look at another problem? I'm going to clear this. Okay, and let us look at this one. If you have 2x cubed minus 3xy squared is equal to c. Remember that this one has one arbitrary constant. So we are only going to differentiate once. So, but remember your calculus 1. In calculus 1, we talk about product rule. Okay, so I'm going to take that into consideration. So let us differentiate. So if I differentiate this guy, the power times the coefficient, and then you subtract 1. So if I subtract 1 here, it's going to be 2. So minus 3, and then I want to use the product rule. Product rule says hold one constant and differentiate the other. So if I differentiate y squared, assuming that you know calculus 1, 2y times y prime plus. So now I want to differentiate x, which is 1 times y squared. And we know that the derivative of a constant is 0. So here we're going to have 6x squared. And then if we multiply everything here, we get negative 6x y prime. And then this negative times this negative 3y squared or equal to 0. But remember, y prime is the same as dx. So I'm going to replace that guy here. So I have 6x squared minus 6x y, wherever I see y prime, I put dy by dx minus cdy squared will be equal to 0. So what I'm going to do, I'm going to multiply this expression by dx. So if I multiply, I will have 6x squared dx minus 6xy dy minus cdy squared dx, all will be equal to 0. So what I'm going to do, I want to group all the dx terms. So I look at this one and this one. So I have 6x squared dx minus 3y squared dx plus, so I group this term minus 6xy dy. So if I reduce by 3, we have, and I notice that, okay, so if I reduce by 3 here, I'm going to have s square, 3 go here is 2. So I'm going to have 2x squared. And then 3 go here, I have minus y squared plus dx minus 6x y dy all will be equal to 0. Yeah, so if you like, you can stop here, and this is going to be our equation. So we will talk more and more, guys. I have more problems I will be coming up with, and then we will talk more. This is just the introduction. Remember, differential equation is very, very, very important, especially to us, the engineers and mathematicians. They are very special. We use them to be able to solve real life problems. So, guys, we're going to stop here for today. I have more videos coming up to solve some more difficult problem, and I hope you will be able to follow me, watch this video, be able to share, and we can share the knowledge together. So thank you ever so much. Love you and have a good time, guys.